All right, in this video, we're going to begin chapter 8. And in chapter 8, we're going to be dealing with descriptive statistics. Basically, in this chapter, we're going to be talking about graphs, how to represent data with graphs. And then we'll go into measures of center and also measures of variation. And then we're going to be talking about measures of relative standing. Mainly, we're going to be talking about percentiles, how to do a box and whisker plot from a data set, and other things. So those are just some of the things we'll look at in chapter 8. Okay, so now this first section deals with the graphical representations of data. So basically, we're going to be talking about things like bar graphs, line graphs, pie charts, histograms, scatter plots. Those will be things that we can represent data by using graphs. Okay. So when we talk about data analysis, we're going to look at 4 phases here. We're going to ask a question worth answering, and then we're going to collect and organize the data. Then we're going to explore and analyze the data using appropriate methods, and then display the data and communicate conclusions based on data. In statistics, we use a topic called hypothesis testing. Okay, here we have a question that we want to answer, like, is a certain drug effective in treating a certain disease? And then we can try to collect the data from that and then analyze it and then display it using graphs or tables or charts and give a conclusion based on that analysis. Okay, so here we have 2 types of variables that we'll talk about first. One of them will be categorical, and the other one will be numerical variables. Categorical and numerical variables is what we'll talk about first. All right, let's define a variable. It is a characteristic that varies from one object to another. You probably heard of this term when you took your algebra classes in previous semesters, where the variable is a letter used to represent an unknown. Here in statistics, it's going to be a characteristic that can vary from one object to another. So if the objects are people, then variables could be things like height or age or hair color, okay? Because those vary from people to people, from one person to another. Now, the objects of books, then variables could be things like the number of pages in one book, the weight of the book, and the binding type. It could be a hardbound or paperback, for example. Okay. Now, the next definition is data. Here, those are observations or measurements from one or more variables. Okay. So if you're talking about a person's height, then that height will represent data, because that person's height varies from one person to another. So you could have numerous type heights. Okay, now let's look at the 2 types of variables here. One of them is a categorical variable. Sometimes it's known as a qualitative variable. Okay, that has values that are labels or categories. So here, the value of a categorical variable answers the question, which category does the object belong to? And here are a few examples, like hair color. It could be black hair, brown hair, red hair, blonde hair. Those are categories. Or the type of movie could be a comedy, a drama, a horror, or an adventure. And in fact, in college, um, a student's classification could be things like junior, a senior, freshman, sophomore. Those are just examples of categorical variables. Now, when we collect information about a categorical variable, we should make sure that the categories do not overlap. Now, a categorical variable may look like a number, such as a zip code, but their arithmetic operations, such as adding and dividing with those values, do not make sense. Like the average zip code is meaningless. Okay, so we can't say that one zip code is greater than the other. Really, that doesn't make sense. So that's just a categorical variable. Also, student IDs are considered to be categorical variable because the student ID number is just identifies who you are. Just like a social security number identifies who you are. Okay. So we can't compare social security numbers and we can't compare student ID numbers arithmetically because those are meaningless. All right, the other type is a numerical variable, which is also known as a quantitative variable. That has values that represents counts or measurements. So the value of a numerical variable, that's going to answer the question, how many or how much. Like, for example, the number of pets in homes is a numerical variable because the value is determined by counting. Okay. So if I can count the number of students in one class, that would be a numerical variable or a quantitative variable because that's done by counting. Also, we can measure something. That too would be a numerical variable. Like the weight of a person is a numerical variable because it has to be measured with a device. That's something that can be measured to a precise number. And anything that can be counted is also a numerical variable or a quantitative variable. Now, a numerical variable or a quantitative variable can be one of two things, either discrete or continuous. Anything that is discrete is something that can be counted, like the number of pets, the number of students in a classroom. That is considered to be discrete because we can count the number of students in a classroom or the number of pets that a person has. Now, continuous is something that can be measured to a precise number. Like weight can be measured to a precise number. Also, time is measured. When a person is participating in a track meet or race, the time that they complete that race can be measured to a precise number. Continuous variables have scales that can be cut into different increments, where discrete values have pre-established increments. Okay. Now, in this next slide that you see here are the two types of variables. Categorical, well, they have the representation of the concept map. The categorical variables are things like marital status, the type of car, hair color. Numerical is going to be things that can be counted or measured, such as the number of pets, the size of the family, the number of cars, time, weight, and also age. believe it or not, is numerical or continuous. All right, in this example here, we want to describe the variable of interest and identify the type of variable. Like the mayor of a town surveys some citizens about the ownership status of their housing unit, such as home, condominium, or mobile home. There were 368 respondents who reported they own their housing unit. So in this case here, we want to find out whether it is a categorical variable or a numerical variable. In this case, it's going to be categorical. And the reason for that is, this mayor was looking for the ownership status of that housing unit. And those are the categories, either a home, condominium, or mobile home. That's a categorical variable in this case. Or qualitative variable. Now in part B, the following table obtained in the observational study gives the number of vehicles that entered the Main Street and First Street intersection during rush hour. And here's that table. We want to determine if it's categorical or numerical. In this case, it is numerical. Because here, they're counting the number of vehicles that entered that particular intersection during rush hour. So that part B, this will be considered a numerical variable or quantitative variable, quantitative. Now part C is the average high temperatures in Chicago Heights, Illinois for the month of January, April, July, and October. And they're given in that table. So in Chicago Heights, Illinois, and we have the average highest temperature, that's considered to be, of course, numerical because they're measuring temperature, as you can see. All right, now let's look at problem number 10 on page 434 in your textbook. Okay, here it says here, we want to determine the type of variable. So in this case here, lifespan of paper money, such as $1 bills, is part A. We want to determine if it's going to be a categorical variable or a numerical variable. We're looking at lifespan, so it has to be numerical or quantitative, because lifespan can be measured, okay, to how many years. Now, part B, the number on jerseys of football players. In this case, this would not be a quantitative. You may think it's quantitative, but it's actually a categorical variable because of the fact where that number on the jersey identifies that football player. So you might think it's numerical because it's a number, but actually some numbers can be considered as qualitative or categorical because we're trying to identify the name of that football player based on the number on that jersey that he's wearing. All right, part C, nationality of survey respondents. That too is qualitative or categorical. Nationality is just identifying, there's several categories for nationality. It could be from the United States, it could be from China or from England or from Australia, etc. Part D is the age group of survey respondents 16 to 19 years, 20 to 24 years, 25 to 32 years, and 33 to 55 years. That's considered to be categorical as well, because we're putting each survey respondent's age into one of those 4 categories. So it's a categorical variable. Part E, salary of teachers. Well, salary is a number, money amount. So that's a quantitative or numerical variable. Part F is telephone numbers. That's categorical. Telephone numbers usually identify that person. Okay. Or identifies the name of the person that has that phone number. So that's categorical. Part G, percent of people in a survey who voted no in the California recall election. This is numerical because we're looking for the percentage of people. We have to count how many people voted no in that survey and then take a percentage of who voted no by how many voted in the recall election. And then part H, weights of people in a sample of elevator passengers. Again, that is numerical as well. Weights can be measured. So if we're measuring a person's weight, then that would be a numerical variable or a quantitative variable. So be familiar with what a numerical variable is and what a categorical variable is and how to be able to identify those two, or identify which one is categorical or numerical. All right, now we're going to talk about how to organize and represent data with tables. Okay, that's the next thing we'll look at here. All right. First of all, the first table we'll talk about is a tally table. Of course, it is a table that shows categories for one variable and tally marks that indicate the number of observations that belong to each category. So usually when you're trying to count, we used to use what they call those tally marks, which is those lines, those short vertical lines going up and down as a way of counting. The other table we'll talk about is a frequency table, and we're going to get to some examples shortly. Now, a frequency table, by the way, is going to be a table that shows categories for one variable and the number of observations that belong to each category. Now, the other table is a relative frequency table. That will be a table that shows all the categories for one variable and the percent of all observations that belong to each category. So in a relative frequency, you're going to be dealing with a percent. The frequency table, you'll just be dealing with the counts or the number of observations for each category. Now, these two tables can serve as an intermediate tool for organizing data in preparation of creating other graphs, such as a bar chart, pie chart, or histogram. We'll talk about those three a little bit later in this video. All right, here's example 6. A teacher surveys the students in the class. He asks the question, how do you get to school? Bus, car, bike, or walk? And here's the table that records the results for the mode of transportation, either by bike or bus or car or walking. So there are 14 students that were surveyed, and this is how they provided their mode of transportation to school. So here on this next slide, let's say we want to create a frequency table for the data and create a relative frequency table for the data. Okay, so here we have to make a table with a list of possible values of the variable and then use the tally method to record the counts. And then we count the tallies to record the number of observations or the frequency in a category. So on this next slide, you're going to see the left table is the tally table. So here on the left side is how students get to school by bike, walking, by car, or by bus. And here, these represent the tallies of each one of those. Okay. And then on the right side is the frequency table. So here they write down the number of people who get to school by bike, which is in this case 4, by walking, which is 7. As you can see here, this represents 5, 6, 7. The car, by car would be 2, and by bus would be 1. So the right side represents the frequency table. Now on the next slide is the relative frequency table. Okay, so here we have to divide each frequency by the total number of students surveyed to obtain a relative frequency table. And here they rounded to the nearest 10th of a percent or to 1 decimal place. So for the bike, how students get to school by riding their bike was 28.6%. And the way they did that is this. There were 4 that reported that they got to school by riding a bike. The total number is 14. There were 14 students who were surveyed. So 4 divided by 14, and then we multiply that by 100%, will give you approximately 28.6%. We round to the nearest 10th or to 1 decimal place. So 28.6% of these students get to school by riding their bike. And then by walking, there were 7 students that walked to get to school out of 14. So 7 divided by 14, multiply that by 100% because you want to change that to a percent. By multiplying by 100, you'll get 50%. And then by car, 2 people get to school by car. So it's 2 divided by 14. And then times 100%. This will be approximately 14.3%. And then finally, 1 person would get to school by bus out of 14. 1 divided by 14, multiply that by 100. That's approximately 7.1%. Okay, so that's how you create a relative frequency table. And keep in mind, the relative frequency table does have percentages for each category. All right, so let's look at problem number 1 on page 433 in the text. A student records the results of a brief survey of some classmates' preferences. And here is that table for those 8 students and whether they prefer soda or juice. And here you're going to use each type of table listed here to represent the students' preferences for soda or juice. So here we're going to create a tally table, then a frequency table, then a relative frequency table. Here's the tally table for part A. And there were only 2 drinks that each student either prefers, soda or juice. And then we do a tally table for that. We just do tally marks here. If you look at it, there's only only 2 people that prefer soda. So that's why you see the 2 marks there for soda. And then for juice, 1, 2, 3, 4, 5, 6. 6 people prefer juice. So here's a tally for the number of students that prefer juice. So that's part A. And now part B. The drink preferred, well, here's the frequency table for that. Well, that's just simple. The drink preferred still soda and juice, and then the tally, there were 2 that prefer soda, so that's the number 2. And then for juice, we write the number 6. And now for the relative frequency table is this. Here we use a percent. Now, for soda, to get the percent of those students who prefer soda, we do this. There were 2 students that preferred soda, so that's 2 divided by 8, which is the total number of students that were surveyed. 2 plus 6, that's 8. So 2 divided by 8, and then we multiply that by 100% to get 25%. So 25% of these students prefer soda. And then for the percentage who prefer juice, 6 students prefer juice from the frequency table. And that's out of a total of 8. So 6 divided by 8, and then multiply that by 100%, that would be 75%. So here's 75% of those students prefer juice. Okay, next we'll look at graphs and exploratory data analysis. Now, graphs in this case are visual representations for exploring, identifying, interpreting, and communicating important features of data sets. They also make text more interesting. So here your students are going to be able to draw a picture, graph, and a bar graph to represent data with up to 4 categories. That's just the expectations. And then answer simple questions about the graphs. All right, let's take a look at this here. Skills for creating various types of graphs are important for exploratory data analysis, where you create multiple graphs for data and then select the graphs that reveal important or unexpected features of data and best supports the conclusion. Okay. Also, when we're dealing with graphs, you want to have creative titles that suggest the graph maker comprehends the data. All right, first we'll talk about bar graphs. Okay, bar graphs are mainly used to display categorical data and are useful for comparing categories. Now, bar graphs uses rectangles separated by equally spaced graphs. And each rectangle represents a category. The rectangles have a common width, and the height of a rectangle is proportional to the frequency or relative frequency of that category. Okay, so in this next example, we're going to compare data in a frequency table called a two-way table. And in a two-way table, each object is grouped according to 2 categorical variables. Sometimes the data are called bivariate data because they depend on 2 variables. For example, suppose a teacher conducts a survey to investigate any possible association between the average number of hours of sleep per night a student gets and that student's interest in mathematics. Okay, so here's that two-way table. So each student or object is asked about the amount of sleep, which is like 5 to 6 hours, 6 to 8 hours, or 8 to 10 hours, and the level of interest in mathematics, low, moderate, or high. So each student in the cell would belong to one cell in that table, and the cells in the table would record the frequencies or relative frequencies. Bar graphs can help visualize the data in two-way tables as well. So here is that table that summarizes the percentage of people with some type of health insurance in 3 chosen states. So that's down here at the bottom. For example, like a 50-year-old person from California would be part of the 79.4% of the people with some type of health insurance. Okay. And here I want to draw a bar graph to visualize the data. And here is that bar graph. Now, there are 2 bar graphs that we see here, and it can be represented either way. Okay. Here, each highlights different aspects of the data. So here, this bar emphasizes a comparison between age groups for each state. So you can see for California, Maryland, and Texas. And notice that it has been shaded. Like the darker shaded bar is for under 65s, the lighter shaded bar, as you can see here, since it's in black and white, 65 years or older. Okay. Another way we can represent that bar graph would be for each age group, under 65, 65 and older, and for each of the 3 states. And forgive me if this bar graph is not clear because I printed it in black and white. But there is a bar for Texas. All right. Now look at problem number 14 on page 435. Let's talk about this one. The table shows the median level of income for various age groups based on the most recent U.S. Census data available. Make a bar graph for the data and include an inference from the chart in the form of a descriptive title for the chart. And here is that table for the age group in years and the median income of males and females. So here is how we create that bar graph. Notice on the horizontal axis going across are the categories here. And this deals with the age group in years. Okay. And I should have put age group in years down here as to identify what that horizontal axis is. 21 to 24, 25 to 34, and so on. The vertical axis that you see going up and down, that's the median income. And here is sectioned off in groups of $5,000, from 5,000 up to 45,000. Now, I pretty much freehanded this, did this by hand. So I pretty much kind of estimated where each one of these dollar values are. But like for 21 to 24, that's 20,502, which is about right here. So that's the height of that bar for 21 to 24. Then for 25 to 34, that's 30,187, which is about right here. Then 35 to 44, that amount was 35,764. That's the height of this bar right here. And then for 45 to 54, 38,145. Kind of estimated because it's near 40,000, but it's not exactly 40,000. And then finally 36,119 for 55 to 64. That would be the height of that bar right there. Okay. So you should be familiar with trying to draw a bar graph freehand. And I think in the homework, they might give you a choice of which one of those bar graphs, and you have to pick out which one of those bar graphs fit this particular table that you see here. All right, take a look at problem number 2. This one, those two-way tables or two-way frequency tables here. A student surveys a few classmates. She asks them, do you prefer smooth or chunky peanut butter? The results are as follows, as you can see here. And let's say I want to complete this two-way frequency table to summarize the collection of data, which I've already did here. So here I had to look at the number of boys that prefer smooth peanut butter. Here, the B represents the boy, S represents smooth, G represents girl, C represents chunky. So here, a B and an S means this boy prefers smooth peanut butter. And here's another observation here. Well, boy prefers smooth and chunky, prefers just smooth, and another boy that prefers smooth. There are 3 boys that prefer smooth peanut butter. So that's why that 3 is here. As for chunky, here are the 2 right here that prefer, the 2 boys that prefer chunky. So that's why there's a 2 there. Now for the girls that love smooth peanut butter, there's only two. Here and here. This girl prefers smooth, and this girl prefers smooth peanut butter as well. So that's only 2. And then there's only 1 that prefers chunky peanut butter. 1 girl preferring chunky peanut butter. So if you were to add all of these together, should end up being 8 observations here in this two-way frequency table. Otherwise, you miscount it. Okay, next we'll look at problem number 7 on page 434. Here's a two-way table representing the results of scores from an exam worth 100 points for non-math majors and mathematics majors. And we want to use that table to answer the following questions. How many non-math majors took the exam? Well, this row represents a number of non-math majors for each category. So you have to add each one of those observations together for non-math majors. So here, if you add 3, 5, 1, 12, 5, and 2 together, you'll get 28. So 28 non-math majors took the exam. Part B, how many students scored fewer than 50 points? Okay, so here, this column represents those who scored less than 50 points here. So if you add 3 and 2 together, you'll get 5 students. So to answer that question, 5 students scored fewer than 50 points on an exam. Now, part C, what percentage of students taking the exam scored in the 70s? Okay. In the 70s, 70 to 79, that's the 70s right here. And it's going to be the 12 and the 5, the 12 non-math majors and the 5 math majors. So if you add 12 and 5 together, you'll get 17. That means 17 students scored in the 70s. But for the percentage, we have to do this. We have to take that 17, divide that by the 58. Now, where did I get 58? In this case, I had to add all these numbers together in the boxes. There were 28 non-math majors. There were 30 math majors. If I add 2, 4, 4, 5, 10, and 15 together, there were 30 math majors. So 28 and 30 gave me 58. So I do 17 divided by 58. But to change that to a percent, because they asked what percent of students, I had to multiply by 100. And this will be approximately to the nearest whole percent, 29%. I think if you did this on the calculator, you'll get a decimal for that, but you have to round to the nearest whole number, 29%, or whatever place value that they asked for in WebAssign. And then part D, what percent of students taking the test were math majors? There were 30 math majors out of a total of 58 students in that class. So 30 divided by 58, multiply that by 100, you'll get approximately 52%. Okay, so that's how we can use a two-way table to answer these types of questions here. All right, next we'll look at a pictograph, or just simply a picture graph, because that's what it is. It has pictures in it, and it uses symbols or icons to represent quantities. Now, a symbol represents a certain value, and the number of symbols is proportional to the quantity represented. Sometimes this means the picture graph contains part of the symbol rather than the whole symbol. And it is similar to a bar graph as well. Here's an example of what a pictograph will look like in example 10. Here the table shows the estimated number of arrests for certain crimes in 2008, based on data from law enforcement agencies. And here I want to make a pictograph for the categorical variable type of crime. And here we're dealing with burglary, motor vehicle theft, and liquor laws, and the number that committed each one of those types of crime. So here, now I realize that it is hard to see, but they're using the fingerprint symbol to represent 100,000 arrests, as indicated there. 100,000 arrests, and they're using the fingerprint symbol. Okay. So we can see the number of arrests for liquor law violations is about 6 times the number of arrests for motor vehicle thefts and twice the number of arrests for burglaries. Okay. Now we won't do any problems that are dealing with pictographs here. I just wanted to briefly talk about what a pictograph is and what it looks like. Also, we'll look at a pie chart or a pie graph. I'll just briefly talk about it, but I won't have you do an example of that. Here we can visualize numerical or categorical data using a pie chart or a pie graph to show part-to-whole relationships, much like fractions and percentages. We did talk about part-to-whole back in a section back in chapter 5, I believe, or 6. I'm not sure. But pie charts require non-overlapping categories. So here the main idea is going to be a circular region representing the whole, and each sector or slice has a central angle that is proportional to the quantity that the sector represents. Okay, so here in this next example, we're going to illustrate how to use a bar graph and a pie chart to visualize numerical data. So here we have to create categories and lose the individual bowling scores. So here's that table showing the bowling scores of a class of students, as you can see here. And we want to represent this data using a bar graph and a pie chart. Okay, so let's talk about what a bar graph could be for this data. So here we need to create categories. Something like this: 69 or fewer, 70 to 79, 80 to 89, 90 to 99, and 100 or more for the scores, and record the number of observations that belong to each category. And it could be other categories as that you could use, like 50 to 59, 60 to 69, and so on. But here we're just using these. Okay. So for 69 or fewer, there were 4, because you had to count how many from this table here had scores of 69 or fewer, and there were 4. Then for 70 to 79, there were 6. 80 to 89, there were 7. 90 to 99, there were 2. 100 or more, there were 3. So you have to usually count from that particular data set that I just showed you on the past slide. Now I'm going to skip this slide here because this is kind of confusing for some of y'all if you're not familiar with the angle of a sector, because that's what they're using here to create a pie chart. So this is what the bar chart looks like on the left side. Notice that it is in categories. The bowling score is the horizontal axis. The frequency is the vertical axis. And here they came up with the title, Most Students Scored in the 70s and 80s. And this is what the pie chart looks like. Now, the reason why I would not talk about pie charts in detail because Microsoft Excel does create pie charts for you. Okay. Microsoft Excel does create the pie chart for you. So like, let me see if I can go to this. All right, here's an example of this, and this is in percentages. When we're dealing with activity like social networks, online games, email, portals, instant messaging, videos, and search. Okay, let's say I want to create a pie chart for each one of these activities here. Okay, so what I'm going to do is try to highlight this, and then hopefully I can find this here. Okay. Let's say I want to insert something called a pie chart. Yeah. So here's a symbol for a pie chart right here. And if I want to do a two-dimensional pie chart like this, click on that. Here it already does the pie chart for you. And you can enhance this to include percent for each one of these, or do a chart style. Yeah. Things like that. You can use that to try to create a pie chart, make it look good. But here, I won't go into much detail about that because pretty much it can be done on Excel. And also, let me warn you about this. A graphic designer discourages the use of pie charts because of the amount of ink that it takes to even print a pie chart on paper. So this, where it's got 40% for social networks, this right here takes an awful lot of ink for that. All right, so now, so much for pie charts. We'll talk about, we'll just end it there. All right, next we'll talk about a line graph. Also, Microsoft Excel does line graphs for you. Now, a line graph is suitable for visualizing two related numerical variables, x and y. So in a line graph, we just plot the ordered pairs x comma y and connect the ordered pairs with line segments to visualize any trends. Okay. And a time series plot or a time series graph is another name for a line graph in which the horizontal axis represents a time variable, as in this next example that we're going to see right here. Here the table shows the number of burglaries per 1,000 households in the United States from 1994 to 2002, according to the National Crime Victimization Survey published by the Bureau of Justice Statistics. Make a line graph for the data, and what does the graph show? Okay, so here we got the year from 1995 to 2000, 1994 to 2002, and the burglaries per 1,000 households. So here is what the line graph looks like. And by looking at this, you're going to see that the burglary rate is steady declining. So you can see this is falling from left to right. So it is steadily declining. Okay. So the line graph is affected by the scale of the axis and the physical size of the graph. For example, if we were to change the scale of the y-axis, as you can see here, and we were to plot it based on that vertical axis that you see, notice it's still declining, but it seems to be declining at a rapid pace. So as you can see here, this is kind of this graph can be quite deceiving to some people. And this can be dependent upon how you set up your vertical axis and your horizontal axis. The vertical axis can make it look like this burglary rate is declining at a fast pace. But here, to be truthful and to be honest, you want to show it by starting with 0 up to 60 and not from 25 as it is shown here. They start with 25 up to 60. Start from 0 to 60 to be on the safe side. Now, let's take a look at problem number 49 on page 439. The following line graph shows the number of federal correction facilities in Canada from 2000 to 2008. And in part A, we want to find out which years experienced an increase in facilities compared to the previous year. An increase. Well, take a look here. In 2001, well, right here, there was an increase compared to 2000. Also in 2003, there was an increase compared to 2002. In 2004, there's another increase compared to 2003. And then there was another increase right here in 2007, and that's compared to 2006. So these are the years that experience an increase in facilities compared to the previous year. That's part A. Now part B, what year experienced the greatest increase in facilities compared to the previous year? The greatest increase, I think it's going to be right here. Where this big jump starts from 53 up to 58. And it happened in 2007. So that's part B. Now part C, which years experienced a decrease in facilities compared to the previous year? That means it has to be falling from left to right. Here, from here to here is decreasing in 2002 compared to 2001. There's another huge decrease right here from 2005 to 2006. So in 2006, there was a decrease. And in 2008, there was another decrease. So here, 2002, 2006, and 2008 were the years that experienced a decrease in facilities. And then part D, which year experienced the greatest decrease in facilities compared to the previous year? Well, here's the huge drop right here from 58 down to 53. And that happened in 2006. Okay. So that's how we use a line graph to answer questions that are related to it. Okay, next we'll look at a scatter plot. A scatter plot is a graph of a collection of ordered pairs x, y, where x and y are numerical variables or quantitative variables. The purpose of a scatter plot is to make it easier to see whether there is a possible association between the variable x that's along the x-axis and the variable y along the vertical axis. Now, in a scatter plot, it's just going to be points that are scattered. We don't connect the ordered pairs with line segments. It's just going to be dots on a coordinate plane. That's all it is. And in this example here, well, in this slide, there are 4 illustrative scatter plots of some possible associations between x and y. The first one is a positive linear association. That means that here, the points are increasing from left to right, as you can see. They're increasing from left to right. That's a positive linear association. A negative linear association would be something like this. As you can see, the points are falling from left to right. So as x increases, the y values decreases. And in a positive linear association, as the x values increase, the y values increase. The third one is a non-linear association. Here, non-linear, they don't form a straight line. It forms a pattern, but it's not in a pattern of a straight line. And then the last one would be no association, meaning that the points are just scattered all over the place. There's no linear association with that, with x and y. Now, in a scatter plot, we look at the direction and the shape of the dots. So let's look at example 15 here. The following table shows the total number of points scored and the number of wins by the 32 NFL teams during a regular season. And here I want to find out, does there appear to be a correlation between the number x of points scored and the number y of regular games won? Let's say I want to construct and analyze a scatter plot for the data. Now, let me mention that Microsoft Excel does create scatter plots for you. Okay, you just have to enter probably in the first column your x values, and then in the second column will be your y values, and then select the scatter plot feature. Now, here is that scatter plot. Okay, so by looking at this, we see it does have a positive linear correlation because the points are increasing from left to right in this case. So here the scatter plot suggests that during the regular season, teams that score more points in a season tend to win more games overall. Okay. So the more points that a team score, the more often that the team wins their games. All right, next we'll look at a histogram and how to create a histogram. A histogram is a visual representation of a frequency or relative frequency table for a numerical variable and is especially suitable for displaying and visualizing a large collection of numbers. And here there are several visual differences between a histogram and a bar graph. Here they are. The rectangles in a histogram touch each other, where the rectangles in a bar graph are separated by arbitrarily but equally spaced gaps. So the histograms will be touching each other. Okay, the bar graphs that we looked at were just separate, equally spaced. Also, the rectangles in a histogram must appear in their natural order along the number line, whereas the rectangles in a bar graph can appear in any order. Okay? They have to appear in their natural order. We're going to talk about that a little bit later. You'll see an example of that. Also, constructing histograms requires some experimentation with selecting the number of groups to attain a shape that reveals a useful or interesting characteristic of the data. And here those groups are inequalities of the form where x is greater than or equal to a and less than b. And each group should have equal width. All right, now let's look at this example number 16, where the following data represents 107 measurements of the durations of eruptions in minutes of the geyser Old Faithful. This is what those 107 measurements look like. And we're going to take that and represent this using a histogram. Okay, so follow along with me because this is spread out over so many slides here. So here there is great flexibility in constructing the histogram. So here you get to choose a number of groups. Each group is an interval of the form where x is greater than or equal to a and less than b. And each group should have an equal width where the width is going to be b minus a. That's the upper endpoint minus the lower endpoint, b minus a. So you want to make sure every measurement belongs to some group and those groups do not overlap. So here you have to kind of be creative by trying different choices to see what the graph looks like and choose a histogram that seems to display an interesting feature. Okay. So here's the steps here. First, we calculate the difference between the extreme values here. In that data set that I just showed you, and I'm going to scroll back up here so that way you can get familiar with what that data set here is. This is the data set we're talking about. You want the highest data value and the lowest data value that's in this data set. And based on that, the highest and lowest measurements are 4.93 minutes and 1.67 minutes. So we're going to subtract the 4.93 minus the 1.67 to get 3.26. That's something called the range of the data values. We'll talk about that in the next section. And then you're going to choose a number of groups. So here you want to create, let's just say 8 groups. I mean, you could use 5, you could do probably 9 or 10, but here they're just choosing 8 groups. So if we divide 3.26 by 8, you're going to get this number 0.4075. That's to determine the width of each group. So here you're going to choose a width slightly larger than 0.4075 so that the largest value, 4.93 minutes, in the data set belongs to the last group. Now here, they're going to choose a width of like 0.41, which is slightly larger than 0.4075 because it's convenient. All right, now here we're going to create our groups. The lowest measurement is 1.67. So if I add 0.41 to 1.67, I'm going to get 2.08. So that means the first group is going to have this interval, 1.67, less than or equal to x, and less than 2.08. Okay, it automatically contains the lowest measurement, but it will not contain 2.08. And then we just add 0.41 to the lower and upper boundaries of the first to obtain the second. So in this case here, 2.08 plus 0.41, that gives you the 2.49. That means your second group will be containing 2.08 up to 2.49. Does not include 2.49 because of that. Less than. It's going to be greater than or equal to 2.08 or less than 2.49. And as before, we just add 0.41 to the lower and upper boundaries of the second group to obtain the third group. So if I add 0.41 to that 2.08, that would be 2.49. And then add 0.41 to the 2.49, that would be 2.90. So this is what the third group looks like. Here you have less than or equal to here, and then less than, strictly less than on the right side. And we just repeat that process, making sure the last group contains the highest measurement. And then we create the frequency table. So this is what the frequency table looks like. That's what the frequency table looks like. And then they count the frequencies that the data values are between 1.67 and 2.08, but not including 2.08. That's 25. Then 2.08 including the 2.49. Not including the 2.49 would be 4, and so on. And then next we create the graph. Include a title and label the axis as well. Now there are no arbitrary gaps between the groups unless a group has a frequency of 0, and the groups must be placed in their natural order. Also report the midpoint of each category on the number line. Now, let's talk about how to do a midpoint on this next slide. Take your endpoints, add them together, divide by 2. Like 1.67 plus 2.08, that would give you 3.75. Take that 3.75 and divide that by 2, you'll get 1.875. That would be your midpoint for the first interval. The next interval, 2.08 to 2.49. Add those endpoints together, divide by 2, you'll get 2.285. That would be your midpoint for the next interval. And then 2.49 to 2.90, add those two endpoints together, divide by 2, it'll be 2.695. That would be your midpoint for the next interval. And you'll do the same for all the others. And this is what your histogram looks like. Okay. Let's take a look at this particular problem number 53 on page 440. The histogram shows the average number of points scored per game by basketball players. And here I want to complete the frequency table for the histogram and what percentage of the players average at least 25 points per game. So let's start with the frequency table. On the left side, you'll see the interval. Okay. Now I kind of had to guesstimate on this one right here because this looks less than 15. So here between 10 and 15, that's about 13 up to 16. So that's my interval. X is greater than or equal to 13, but less than 16. And the height of that frequency, that bar for that frequency, for the histogram you see here is 2. And then this next one is for 16 to 19. And notice that the width here is 3. From 13 to 16, that width is 3. So if I add 3 to the 13, that's going to be 16. Add 3 to the 16, you get 19. So this represents some x value greater than or equal to 16, but less than 19. And that frequency there in that histogram is a 3. And then the next one's from 19 to 22, adding 3 to each endpoint here. Between 19 and 22, including 19, that height there is 11. So that's where the 11 comes from. And then add 3 to your endpoints, you get 22 to 25. The height there is a 5, because that's halfway between 4 and 6. Then the next one, 25 to 28, the height there is 7. And then finally from 28 to 31, the height there is a 2. Okay. Now part B, what percentage of the players average at least 25 points per game? At least 25. So it's got to be these final 2 intervals here. 7 average between 25 and 28, and 2 average between 28 and 31. So if I add 7 and 2 together, I'm going to get 9. But they ask for the percentage. So I need the total frequency. So I had to add the 2, the 3, 11, 5, 7, and 2 together to get 30. So I had to do 9 divided by 30. 9 is the total number of players that average at least 25 points per game, divided by the 30 players times 100%. That gave me 30%. So to answer the question, 30% of the players average at least 25 points per game. And page 441, problem number 54, is a table that shows the percentage of 8th grade students who scored at least at or above basic proficiency on the NAEP test for mathematics in 2007. That's the table right there. Now we're going to use that to complete the frequency table. And you're going to add more rows if necessary and construct a histogram for the data. There is a problem in WebAssign that's kind of similar to that. Now they will already have the intervals set up for you. So you won't have to worry about trying to create these intervals here. They're going to have those intervals set up for you. And here, you just have to come up with the frequencies. So like below 50, if you were to look through that table, you will not find any data values that are less than 50. So that's 0. Between 50 and 55, there will be only 1. 55 to 60, there'll be 4, and so on. So that's what the frequency table looks like. You just have to count how many data values are in that original data set that is within each one of those intervals. So this is the entire frequency table here. Then part B is to come up with your histogram, which is what they want. And of course, the midpoints, if you recall, what I did here is this. I took I added the two endpoints together, 50 and 55. That gave me 105. To get the midpoint divided by 2, you'll get 52.5. So this is 52.5 for that first interval, which is 1. And then for 55 to 60, I did the same thing. 55 plus 60, that's 115. 115 divided by 2 will be 57.5. Okay. And notice if you want, and there are ways you can get these other midpoints here, because here, if you look at the distance from these two upper endpoints, that's 5. So if I take 52.5, add 5 to it, it's 57.5. Add another 5 is 62.5. Add another 5, that's 67.5, and so on. And then I do the heights of these bars right here. And I think in the homework, they're going to ask you to select the bar graph that fits that particular data set. And also, you just have to, you'll have your intervals prepared for you. You just have to fill in the frequencies there. Okay, so this concludes this particular video on section 8.1 that deals with graphical representation of data. Okay, please feel free to email me if you have any questions or concerns about this, about the homework in WebAssign for this particular section. Hopefully I will see you in class next time.